infinity of f of x dx is less than the actual sum is less than s sub n plus integral into infinity f of x dx, which equals u sub n. You have to remember that the one on the left begins at n plus 1. The one on the right begins at n. So if the one on the right is going to be greater, then it has to start a little to the left to grab a little bit more area. Does that make sense? If this is going to be less, it's got to begin a little bit to the right, so you calculate less area. That's the way I remember it. But a lot of times people think n plus 1's got to be on that side because it says this is less than that, and that's backwards. Okay, be careful with that. All right, let me erase that, pull down the screen, and let's look at those last two problems. Oh, you can't see it. Here we go. Consider the following convergent series. So they give us that it converges. Does this have any point if it diverges? No point, right? You can't, if the remainder is infinity, this doesn't do anything for us. Okay, so they give us that this converges. We have the sum of, as k goes from 1 to infinity, of 5 over 6k to the 4th. So, all right, part A says, use an integral to find an upper bound for the remainder in terms of n. The upper bound for the remainder is blank. So use an integral for the upper bound of the remainder. That would be this. We're on the upper bound side. S sub n, so that you approximate the sum of the series with n terms. This is the remainder. Those are the terms beyond. That's the area beyond n. Does that make sense? So this is what they're talking. If it said lower bound, then we would be using this one. Okay. All right, so here we go. This is part A. I'm going to do the integral from n to infinity of 5 over 6x to the 4th dx. I'm going to rewrite that as 5/6 on the outside and x to the negative 4th on the inside. And then we'll get the limit as b goes to infinity of 5/6 times the antiderivative of this. Add 1, we get -3, so x to the negative 3rd over -3 from n to b. Let's clean that up a little bit. So it would be -5/18. I'll do over 18 x to the third. So -3 times 6, that gave us 18, I put the negative there. X to the -3rd, I put it in the denominator. So we get the limit as b goes to infinity. -5/18b to the third minus -5/18n to the third. What is going to infinity, n or b? B is. That means this goes to 0. Minus minus is plus 5. N is treated as a constant. B is the variable of the limit. So this simply equals 5/18 n to the third. Go. Okay, any questions there? Remember, this asked for an upper bound, so that means the lower bound of the integral was n from here. If it had asked for a lower bound, this would be n plus 1. We would be doing this one, okay? If it had been a lower bound. All right, part B. I'll pull that up when I do the work here so I don't walk your view over here. Part B. Find how many terms are needed to ensure that the series is less than, to ensure that the remainder is less than 10 to the -3rd. So, find n so r sub n is less than 10 to the -3rd. All right, well, this represents our remainder, doesn't it? Right? Because we have S sub n, the sum of the first terms plus this, that gives us an approximation for the total sum. That's our remainder. And we want to find n so that our remainder is less than 10 to the -3rd. So we want 5/18 n to the third to be less than 10 to the -3rd. Ten to the -3rd is 1/10 to the +3rd, which is 1/1000. Okay? So 5/18 n to the third less than 1/1000. We need to solve this for n. Take the reciprocal of each side. Now, do you all agree that 1/2 is less than 3/4? Do you guys all agree with that? But if we do the reciprocal, 2/1, 4/3, now which side is less? 4/3 is less, isn't it? Because that's like 1 1/3. That's less than 2. So if we do the reciprocal of each side, this needs to reverse direction. Okay? Now let's multiply by the reciprocal of 18/5, 5/18. So that these all cancel out. 1,000 times 5 is 5,000. Okay? Don't worry about reducing. We're trying to get n by itself, so now we need to take the cube root of each side, which is the same as raising each side to the 1/3 power. So 1/3 times 3 cancels out. We have n greater than this. And now we need to get an approximation for that decimal form. And it says round up to the nearest whole number. Okay, so in my calculator, in parentheses, I'm doing parenthesis 5,000 divided by 18 in the parenthesis. Now I'm doing exponent key and a new set of parentheses. In those I'm doing 1 divided by 3 equals. I get 6.52477. Okay? We cannot take a partial term. And we can never round down, because rounding down would reduce our accuracy. So no matter what it is, we always round up. If you got 6.001, you would round it up to 7. Does that make sense? So this is going to give us 7 after rounding. Now let's think about what that means. That means if we add the first 7 terms of this series, our result will be within 1,000th of the actual sum. That's pretty good, isn't it? Just adding the first 7 terms will give us a result within 1,000th of the actual infinite sum here. Okay? All right, now it says, use an integral to find the lower and upper bounds, L sub n and U sub n respectively, on the exact values of the series. So we already have our lower bound, our upper bound here. See up here? Find an integral to find the upper bound. That's this, 5 over 18n cubed. That's the answer here, 5 over 18n cubed. If we had found a lower bound, what would have been different in this work if we had been finding the lower bound rather than the upper? This is for the upper. What would change if we were doing the lower? We'd use n plus 1, right? And if you follow it through, in the end, you would just have n plus 1 cubed there. That would be the only difference. Does that make sense? So, let me write up here, over here. Lower bound, L sub n would be n plus 1 to infinity of 5 over 6x to the 4th. And I'm going to skip all that work. The final answer, 5 over 18n cubed, would be 5 over 18 times n plus 1 cubed. You can go through all the steps, but that's how it will work out. Trying to save us some time. Any questions about these? So now we have an expression to find the lower bound of our remainder, and we have one for the upper bound. Now look what this says. Find an interval in which the value of the series must lie if you approximate it using 10 terms of the series. Using 10 terms of the series, the value lies in the interval. Okay. To do that, we have to do S sub 10. That means we have to add up the first 10 terms, and then we need to put 10 in for n here, and calculate this integral, and add it to this. Then over here we need to take the sum of the first 10 terms, put 10 in for n there, calculate that integral, and add it to that. That'll give us an upper and a lower boundary. Does that make sense? Fortunately, we already did this, and we already have this and this. So to find these pieces, what we're doing to answer this is we're doing this and this with n equals 10. So you got to find S of 10 and put 10 in here. Find S of 10 and put 10 in there. That'll give you the answer for this. All right? Okay, let me erase this work. Let me just put 5 over 18 in cubed there. Just erase the work, get it out of the way. Let's erase this. We don't need this anymore. Now that one over there, lower bound. We didn't take any pictures of that. This is the upper. The lower is 18 times n plus 1 cubed. This is the lower. All right, so we need to find S sub 10. Oops. 10. That means we put in 1 and we get 5, 6 times 1 to the 4th, plus put in 2, 5 over 6 times 2 to the 4th, plus 3, 5 over 6 times 3 to the 4th, plus ... plus the 10th one, 5 over 6 times 10 to the 4th. Now, how many of you are excited about working all this out, getting a common denominator? No, I'm not excited about that. The internet to rescue. On our Canvas homepage, there's a link down here that says Series Calculator. Click on the Series Calculator. We get this. So, summoned. This is our expression. The 5 over, where do I have it? The 5 over 6k to the 4th, that's what this is, except what variable do they use? N. So rather than putting k, we're going to put n. So 5 over, I'll put parentheses, 6n to the 4th. And then, I thought they put it here somewhere for us, apparently not. Variable n, start value 1. We're going to go with the first 10 terms. You can put any number here. I don't know if it eventually errors out or whatever. And then go down here and click calculate. Here it gives us each one, the fraction value for each one, and then the totals. So if you get a common denominator and add those, you get this, and so on. So our final answer, look at that fraction. Imagine getting a common denominator and adding it up to get that fraction. Would that be horrible? I don't know if I could get that right. I don't think I could get it right the first time. I don't know. Fortunately, we're going to be able to use decimals. Here's our answer in decimal form. Okay? So S of 10 is approximately 0.901697. Uh, 1529.11.464. 1529.11.464. There it is. All right. Now we do this. This S of n is this answer. I'm just going to write 0.901. We'll use more decimals when we actually do it. Plus this, which this is the lower side, so that's this one. We got to put in 10 for n. So plus 5 over 18 times 10 plus 1 for the fourth is less than the actual sum. Okay, it goes from 1 to infinity. 5 over 6k to the fourth, that's this. Which is less than this again, 0.901 plus the upper 5 over 18 times 10 to the third. Now you can do this on a regular calculator. I like to use the decimals calculator for this. Notice down here it says round to how many decimal places? 9. We need 9 decimal places. So let's grab the Desmos Scientific Calculator. Down here you click on Scientific. And so let's see. Back here where we did the, I didn't close it, did I? Here. We can actually highlight. I don't know if right-click copy works, but Control-C does. Sometimes when you're doing this web stuff, you have to do Control-C and then Control-V. So there's that number plus 5 over 18 times 10 plus 1 is 11 to the fourth. So here's our answer. I'm going to highlight it.
Isn't it to the third?
Is it to the third?
The lower bound over here is to the third. And this side?
Oh. Yeah. That should be to the, this here should be to the third.
Yeah, so.
I got thirds up here too. I don't know why I'm looking for. Thank you. That should be to the third. That would have been very frustrating. Frustrating. Okay, let's write that down here. So in case we screw it up, in case I screw it up on the computer screen we have here. So 0.901697. That's 6 decimal places. 152, which is going to round to 153, correct? All right, what I like to do from this decimal, I like to highlight the answer, Control-C, Now go to where we're gonna put it in here. We're doing it intervals, so we have to do a parenthesis, then control V. Now we needed to round to 9 decimal places, so if I count these, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, I gotta take 1 off. So the 5 on the end has to come off, but that 5 rounds the 1 to a 2. So we gotta take off the 5 and make the 1 a 2, comma. Now we have to get the upper bound, okay? That means we need to calculate this. Wait, why did I put 3 here? I put the wrong number here, guys. This was supposed to be the sum. I put this answer here, didn't I? Is that what I did? What I put here is supposed to be these two added together. So, from Desmos, it should be this answer, not this number over here. It should be this answer. These two added together, which I believe I did that right, is 0.901, 901, 905, 851. 901. Did I get it right? Yeah. All right, now we have to do the same here. We have to have this number plus that number. So hit return, get you a new one. That first number is sitting right here, so we can copy and paste that down here. And we can take this, include the plus, copy it, well actually we could have just copied and pasted the whole thing and changed that 11 to a 10. There is our upper bound. That's why I like Desmos, we have these copy and paste options. Now we got to round it to 9 decimal places, and there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So the 7 rounds the 0 up to a 1, and then we put our parenthesis on there, and we check it. What happened? Where did we go wrong? Using the first 10 terms of this series, that's like what we did in Desmos. Is this correct? 5 over 6k to the 4th, 5 over 6n to the 4th. That was the problem, correct? 5 over 6k to the 4th, that's good. And we did the first 10. There it is, there it is. There's our decimal. We copied and pasted this. That number. Now for the, oh, do I have them backwards? Is that what I did? No, that should be good. This one should be the lower, right? 901, 905, 901, 905, 901, 905, 852, 851 rounds up to a 2. There's 9 decimal places, 1, 2, 3, 4, 5, 6, 7, 8, 9. That's good. 90197, 49, 31, 49, 37 makes the 01. I just did it in my office with the previous, before I clicked similar exercise, and it was right. What went wrong here? I'm thinking,
Do you have them backwards?
how's that?
Do you have them backwards?
Well, that's what I was thinking, but no, this one's 90, these digits are 905 and these are 974, so that's larger. Round to 9 decimal places, use the answer from part C to answer this part. The only thing I can imagine is that this calculator is not correct, but how can that be wrong?
The term on the left is supposed to be the upper or the lower bound?
The lower.
Okay.
This was correct. The n+1 is correct. We're doing 10 terms.
Is that pi relevant
Say that again?
on the series calculator? Is the pi attached to the final answer?
That little thing?
Yeah.
That's an A.
Oh,
That changes font or something. This answer here should be the same. Maybe not. 901,697.